Dear students, today we are going to discuss a very important chapter of class 12, that is integrals. Integrals, we can say it is an antiderivative, and we can also say it is the inverse process of derivatives. Let us consider a few functions. Let us consider f of x equal to sin x plus 3, and also let us consider one more function g of x is equal to sin x plus 5. Now let us differentiate both of these functions. D by dx of f of x is cos x, and d by dx of, that is derivative of g of x, is also cos x. Now if we are looking for an antiderivative, that is a process by which if we integrate these functions, we must get the answers as these functions. Now let us consider the operation integral. Integral is the reverse process of derivative, that is, if we integrate cos of x with respect to d of x, we call this part as integrand and this symbol as integral of this function with respect to x. We must get the answer as sin x, but we can see when we differentiated sin x plus 3, we got cos of x as the derivative, and when we differentiated sin x plus 5, we always get the derivative as cos x. That means we cannot tell this constant, we cannot tell about this constant exactly while we are doing the reverse process of this function. That means we cannot tell about the constant, whether it is 3 or 5 or any other constant. So we write here as c, which is called constant of integration. Constant of integration. We always leave this as the constant c while doing the reverse process or antiderivative of the function. Let us consider two properties. If we are given a function f of x and g of x and we want to integrate the sum of these two functions, then we can integrate them separately. That means we can integrate f of x and we can integrate g of x separately, and then we can add these. This is property number 1. Now the property number 2 is, if there is a constant multiplied by a function, then we can always write this function outside the integral, and we can say the k, it is k times the integral of f of x dx. Dear students, as this is a formula based chapter, so you can note down the formulas which are coming on the screen. Now let us do some problems based on the first method, that is called integration using the method of inspection. Now consider one function cos of 2x dx. Now we want to find the integral of cos 2x, but by the inspection method. Let us consider the function sin 2x. We know that the derivative of sin 2x is 2 cos 2x. That means if we divide this function by 2, now we get the derivative of this function as cos 2x. That means by inspection we have found the result of this function. Now we have to write plus c if we want to integrate this function. So the answer is sin 2x by 2 plus c, as we can see. Now if we want to check whether the answer is right or not, now let us derive this by finding the derivative of the function sin 2x by 2 plus c. Now the differentiation of sin 2x is 2 cos 2x by chain rule, and divide by 2 was already there, plus 0, because the derivative of a constant is always 0. Now we can see that this answer came out to be cos 2x, which is our integrand in the previous question. Hence, we have verified that the integral of cos 2x is sin 2x by 2 plus c, which is by the inspection method. Now, let us do some problems based on the direct formulas of integration. You can see on the right screen that there is a formula written that integral of x raised to the power n is x raised to the power n plus 1 upon n plus 1 plus c. Now, the integral of ax square, we can do it as the separate functions plus bx b of x plus integration of c d of x. Now, the integration of this function can be written as a x square d of x plus b x d of x plus c d of x, right? So now the integration is x cube by 3 plus b x square by 2 plus cx plus, now we have to write the constant of integration, but we have already used c, so we'll use here constant d. Now let us consider one more function, one more integral, that is x cube plus 5x square minus 4 by x square dx. Now we will separate these functions as x cube by x square plus 5x square by x square minus 4 by x square. Now we can write it as integrals x plus 5 minus 4 x raised to the power minus 2 dx. Again, we'll use the same formula and we can get answer as x square by 2 plus 5x minus 4 x raised to the power minus 2 plus 1 by minus 2 plus 1. Now, plus a constant of integration, that is c. The answer will be x square by 2 plus 5x minus 4 x raised to the power minus 1 by minus 1 plus c, which is equal to x square by 2 plus 5x plus 4 by x plus c. Now let us consider one more function, 1 minus x root x. Now we'll multiply root x by both the terms, that is we get root x minus x root x dx. Now we can directly integrate this if we know the power of this function x. Now this is x raised to the power 1 plus 1 by 2, that is 3 by 2. Now we can use the formula directly, that is x raised to the power n, integral is x raised to the power n plus 1 upon n plus 1. So which comes out to be 1 by 2 plus 1 upon 1 by 2 plus 1 minus x raised to the power 3 by 2 plus 1 upon 3 by 2 plus 1. Again we have to write the constant of integration. Now we can get the answer as x raised to the power 3 by 2 upon 3 by 2 minus x raised to the power 5 by 2 upon 5 by 2 plus c. That comes out to be 2x raised to the power 3 by 2 upon 3 minus 2x raised to the power 5 by 2 upon 5 plus c. Dear students, in this question you can see that there is a denominator present and we'll always try to eliminate that denominator. Now in this case you can see that there are 4 terms present in the numerator and we will take x square common from first 2 terms and we get x minus 1 common. In the third and fourth term we take 1 common and we get again x minus 1. Now we can see that x minus 1 is a common factor to both the terms. Now we can see that this is x square plus 1 into x minus 1 and denominator is already x minus 1. So we can directly cancel these and we are left with the integral, that is x square plus 1 dx. Now we can again directly use the formula which we have already written on the screen, that is x raised to the power n plus 1 upon n plus 1 plus 1 into x raised to the power 1 plus c. That means the answer is x cube by 3 plus x plus c. In this question we can see that there are separate functions and we can separate it out. So we can consider this function as the sum of 3 functions. And we can directly use the formulas for each of the functions. In the first function we can directly use the formula of x raised to the power n, that is x raised to the power n plus 1 upon n plus 1, where n was 1 in the first part. In the second part, we can consider the function as direct integral of cos x, which is sin x. Now 3 sin x, and the integral of e raised to the power x is e raised to the power x, so it can be written as e raised to the power x plus there is always a constant of integration, so the answer is 2 x raised to the power 2 by 2 minus 3 sin x plus e raised to the power x plus c. Now this 2 got cancelled, so the final answer is x square minus 3 sin x plus e raised to the power x plus c. Now we have the function that is secant x into secant x plus tan x. First of all, we multiply secant x with both the functions. Then we can get secant square x plus secant x tan x. Now, first of all, we will separate these two functions. We can get secant square x dx as a first integral and secant x tan x as the second integral. Now, secant square x integral is tan x and secant x tan x integral is secant x. Now, this is the final answer, that tan x plus secant x plus c. In this question, we can see that the numerator is secant square x and denominator is cosecant square x. First of all, we'll reduce it to the sine and cos terms. Secant square x is 1 by cos square x and cosecant square x is 1 by sin square x dx. Now, sin square x will go in the numerator, that will become sin square x upon cos square x dx. That means we have to find the integral of tan square x dx. Now, there is no direct formula for tan square x, but we know that tan square x is equal to secant square x minus 1, which identity we have already used in our previous classes, that tan square x is secant square x minus 1. Now, we know the direct formula for the integration of secant square x and we know the formula for integration of 1. Now, the secant square x integration is tan x and the integration of 1 is x plus c. This is the answer. In this function, we can see that the numerator is 2 minus 3 sin x and denominator is cos square x. Now, we consider this function as 2 by cos square x minus 3 sin x by cos square x dx. Now, we will separate these two functions and we can get that 2 1 by cos square x is secant square x minus 3. Now, we'll split this like this, that sin x by cos x into 1 by cos x. We split the function cos square x like this. Now, we can say that sin x by cos x is tan x and 1 by cos x is secant x. Now, the integral of 2 secant square x dx minus 3 tan x into secant x dx. Now, the direct formula for both these functions are there, that we can say this is equal to 2 tan x, because the integral of secant square x is tan x and the integral of tan x secant x is secant x. So, the answer, final answer is 2 tan x minus 3 secant x plus c. Dear students, now we will do a very important method of integration, that is called method of substitution. Now, we will do the integration by the substitution. Why there is a need to do the integration using this method? Because when the functions are not in the standard forms, that is not in the standard formulas. Now, let us consider one function, that is sine of 3x dx. Now, this is not in the standard form and every time the inspection method will be a lengthy one. So, we will develop one more method, that is called integration by substitution. We will put 3x is equal to t and we'll differentiate both sides. Now, the derivative of 3x is 3, we'll write dx along with this, and the derivative of t is 1, we'll write dt along with this. Now, we'll substitute this complete part in the question. That will give us sine t. Now, dx is equal to, we can find dx is equal to 1 by 3 dt. So, we can write it as sine t dt by 3. So, now we can find the integral of sine t dt with respect to t. Now, the answer will be 1 by 3 into sine integral is minus cos t plus c. Now, we'll put the value of t as 3x. From the question, we have already substituted. Now the answer would be minus 1 by 3 cos 3x plus c. Now let us consider one more function, that is tan x. We know the standard integral of this, but let us derive that using the method of substitution. We can write sin x by cos x as tan x. Now we can substitute cos x as t. Cos x is equal to t. Now the derivative of cos x is minus sin x dx is equal to dt. That means sin x dx is equal to minus dt. Now we'll substitute all these things in the equation. We can write the part as integration of, now sin x dx is minus dt, and cos x we have put as t. So now the integral of this is minus log of mod t plus c. Now we'll put the value of t, that is minus log of mod cos x plus c. Now we can use the properties of logarithms and we can rewrite it as log of mod secant x plus c. In this question we can see there is a denominator present, and we'll always try to substitute the denominator as t because we don't know the direct integrals of the denominators other than the linear functions of x. So 1 plus x square, let it be t. So derivative of 1 is 0 and the derivative of x square is 2x dx is equal to dt. We'll substitute this in the question and we will get dt upon t, which is equal to log of mod t plus c. Now we'll put the value of t from the given substitution. So we can get the final answer as log of mod of 1 plus x square plus c. In this question we have log of x whole square by x. In this we'll put log of x is equal to t. Now you can understand that it is very critical to know what we have to substitute. Now we have to find the derivative of this function. That log of x derivative is 1 by x, and we will write dx along with this, and derivative of t is 1, we will write dt along with this. Now we'll substitute the value of 1 by x dx from the question is as dt and log of x as t. So we can get this integral as t square dt. Now we can use the formula of x raised to the power n dx integral, that is x raised to the power n plus 1 upon n plus 1. In this case we have t instead of x, so we'll get the answer as t raised to the power n plus 1. That means t raised to the power 2 plus 1, which is t cube, by 3 plus c. We'll substitute the value of t as log of x whole cube by 3 plus c. In this question we will consider by putting x square is equal to t. Now the derivative of x square is 2x dx is equal to dt. Now we can get the redefined form of this function of this question as x dx is equal to dt by 2. So we have already x dx present in our question, so it will be dt by 2. We'll write half outside the integral because it is in the multiplication, and e raised to the power x square will become e raised to the power t. Now we can write this as half integral of e raised to the power minus t dt, which is equal to half e raised to the power minus t by minus 1 plus c. Now it will become minus half e raised to the power minus t plus c, which is equal to minus half e raised to the power. Now we'll substitute the value as minus of x square plus c, which is equal to minus half e raised to the power x square plus c. In this question we can see that we don't have a standard function and we have to substitute. That means we have to substitute 2x plus 3 equal to t. The derivative of left hand side is 2 dx, which is equal to dt. Now dx will become half dt. Now we can substitute all these values in the question to get half of e raised to the power t dt. Now the integral of e raised to the power t is e raised to the power t. So we'll get the final answer as half e raised to the power t plus c. We'll put the value of t as 2x plus 3. So e raised to the power 2x plus 3 into half plus c is our final answer. In this question, we'll put tan inverse x is equal to t. So the critical part of these questions is how we will find that this part has to be substituted. We have to consider the complete question and we have to see where is the function and where is the derivative present in the question. In this question, we can see that the derivative of tan inverse x is present. So the derivative of tan inverse x is 1 upon 1 plus x square dx is equal to dt, which is already present in the question. So dx upon 1 plus x square will become dt and e raised to the power tan inverse will become e raised to the power t dt. So e raised to the power t integral is again e raised to the power t plus c using the formula, direct formula. Now we'll put the value of t as tan inverse x plus c. So if we understand what is to be substituted, then the whole question will become very easy. In this question, we'll consider to put the denominator as t, e raised to the power 2x plus e raised to the power minus 2x is equal to t. Now the derivative of e raised to the power 2x is 2 e raised to the power 2x and the derivative of e raised to the power minus 2x is minus 2 e raised to the power minus 2x using chain rule. So this dx is equal to dt. Now e raised to the power 2x minus e raised to the power minus 2x, taking 2 common, dx will become dt. That means e raised to the power 2x minus e raised to the power minus 2x dx is equal to dt by 2. We'll substitute the whole part here and we get half of dt by t. As we have substituted this part as t and we got this as dt by 2. So the answer will be half log of mod t plus c. Now I'll put the value of t from the given substitution. We get half log of mod e raised to the power 2x plus e raised to the power minus 2x plus c. This is our final answer. In this question, we can see that there is a pair present. If we put tan x as t, we'll get secant square x as a derivative. Now, where is secant square x? We have 1 by cos square x present in the question. We'll write it as 1 by cos square x equal to secant square x upon 1 minus tan x whole square dx. If we put 1 minus tan x as t, we get minus secant square x dx, which is a derivative of 1 minus tan x, is equal to dt. Now, if we substitute all these values here, we get minus of dt by t square. Now, we can consider it as a standard function. T raised to the power minus 2 dt will be equal to minus of t raised to the power minus 1 by minus 1 plus c, which is equal to 1 by t plus c. By putting the value of t from the given substitution, that is 1 minus tan x equal to t, we get 1 upon 1 minus tan x plus c as the final answer. In this question, we'll put root x as t. That means the derivative is 1 by 2 root x dx is equal to dt. We have already 1 by root x dx present in our question. We'll utilize it to become 2 dt. So this integral will become 2 cos of root x is t dt. So we know the integral of cos x is sin x. Then the whole answer will become 2 sin t plus c. Now we'll put the value of t here, that is 2 sine of root x plus c. In this question, we can see that the derivative of 1 plus sin x, that is cos x, is already present in our question. So we'll put 1 plus sin x as t. So we get the derivative as 0 plus cos x dx is equal to dt. So now we have cos x dx, we can write it as dt by root t. Now we can find the integral of this using the standard integral. We can write it as t raised to the power minus 1 by 2 dt. Now we can use the direct formula of integration. It will become t raised to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c, which is root t upon 1 by 2 plus c, that is equal to 2 root t plus c. Now by putting the value of t as under root as 1 plus sin x, we get the final answer as 2 root of 1 plus sin x plus c. In this question, there is some indirect substitution. We cannot find direct function whose derivative is present in the question. Now we have sin x into cos x in the denominator. We will multiply and divide this denominator by cos x. So we can rearrange the things and we can rewrite it as root of tan x divided by, we can write sin x by cos x as tan x into, we have cos square x present. Now we can write root tan x by tan x as 1 by root tan x and 1 by cos square x as secant square x. Now we got the standard pair of substitution. If we put tan x as t, we'll get secant square x dx as the derivative of this function. That means we will rearrange these terms and substitute secant square x dx as dt by root of t. 1 by root t can be written as t raised to the power minus 1 by 2. We have already done its derivative in the previous question. So it will be 2 root t plus c. We'll substitute the value of t from the substitution. So we get the answer as 2 root of tan x plus c. So dear students, today we have done the introduction on the integration. Integration is the reverse process of derivatives. So we have done a method of inspection and we have also done how to find the integral using method of substitution. Thank you.